maximum. Here the equation is given in the time domain. Y of n is equal to x of n plus x of n minus 4. So when we have the equation in the time domain, first thing we have to do is we have to do the z transform of it. Okay, z transform. And the z transform is basically we replace x of n with x of z, and if you have a shift, we put it as a power z power. If it's z n minus 4, that's going to become z power minus 4. Okay, this y of n become y of z, and the x of n become x of z, and then x of n minus 4 becomes z power minus 4 times x of z. Okay, so this is our z transform. Now want to if you want to write the frequency response, that is nothing but h of z, that is y of z divided by x of z. So if you divide this one by x of z, this is a y of z. If you divide this one by x of z, x of z divide, that become 1, and then plus x of z divide again, that's going to be z power minus 4. Okay, this is going to be the frequency response equation. Once we have that, then what we do is we do the discrete time Fourier transform. Discrete time Fourier transform is nothing but we replace the z's with e power j omega. Okay, that's the one part. ETFT. In this one, what we do is we replace all the z's with e power j omega. If you do that, then this h of z become h of e power j omega, and 1 remains the same, and then z power minus 4 becomes e power minus j omega 4. Okay. So now the next part, this is the most important part. We have to simplify in such a way that we can draw the we can draw the magnitude and phase diagram. So here we have e power minus j omega 4, and here we have 1. And you have to know one thing here, that if you multiply e power minus 2 j omega and e power 2 j omega, that becomes 1, because minus 2 j omega plus 2 j omega, that becomes 0. The power becomes 0, so e power 0, that's 1. So you can write it as like that. So in that, if we consider that, then we can take e power minus 2 j omega common here. If you take that common, then we are going to have e power 2 j omega here, because to bring it to 1, I had to have the same power, and when you multiply, powers will add, and you get e power 0 and 1 back. Okay, that's the concept. And to get this one here, we have to multiply by e power minus 2 j omega. Okay, so why do we do that is because if we do this one, then we can bring this pattern, and this pattern is helpful for us is to bring the costs, because this e power 2 j omega plus my e power minus 2 j omega is nothing but 2 cos 2 omega. So in that way, we can draw, if we bring that pattern, then we can go ahead and draw the magnitude and phase diagram. So let's go ahead and write that. So this is now e power minus 2 j omega remains the same. Other than that, this part here, e power 2 j omega plus e power minus 2 j omega become 2 cos 2 omega. So 2 times e power minus 2 j omega, and then this cos 2 omega. Okay, this 2 cos 2 omega belongs to this part, and e power minus 2 j omega remains the same. Okay, now once we got that, we can go ahead and we can go ahead and draw the diagram. And also, if you wonder how did I get this, you have to remember this equation, that cos theta is nothing but e power j theta plus e power minus j theta divided by 2. That's how I got this one. Okay, just to illustrate this. So let's look at the magnitude diagram first. So here from this equation, we have to bring a term for the magnitude diagram, phase diagram, and the magnitude diagram. So for the magnitude diagram, that is h of e power j omega, we bring this part along, the 2 cos 2 omega part, we bring that part along. Okay, that is for the magnitude diagram, and the rest of them is for the phase diagram. This part here, this is for the phase diagram, this is for the magnitude. And the phase angle of h of e power j omega, that can be found using this e power minus 2 j omega. H of e j omega, actually that is minus 2 omega, because we have to just look at the angle that multiplies here, that is minus 2 omega. Okay, now let's use this one and draw the phase diagram. So for the phase diagram, let's put the graph. One phase plot. Actually, we are doing the magnitude. Let's do the magnitude first. Magnitude plot. For that one, we are going to use the equation that is, we derived h of magnitude of h of e power j omega, which is equal to 2 cos 2 omega. Okay, so here what we have to do is we have to pick some angles, like for example, if I have 0, then I can take 5 by 4 in this side, and then negative 5 by 4 this side, and then if I add another 5 by 4, that's 5 by 2, then this is 5 negative 5 by 2 here, then 3 5 by 4, then here negative 3 5 by 4, and 5, and so on, minus 5, this 5. Okay, like that we pick some values, and then we plug that one in this equation. So here 2 cos 2 omega, so if I plug minus 5 by 4 in this omega instead of omega, what will happen? Minus 5 by 4 multiplied by 2, that become minus 5 by 2, and cos 5 by 2 is 0. So even if you apply positive one, that's going to end up having some 5 by 2 value. So whenever there's a situation that you get a 5 by 2 value, this is going to be 0. So this one, as you can see, this one will happen every time you have a 4 in the denominator. So that time this is going to be 0. And let's say what happens if I plug negative 5 by 2, 5 by, and also let's see what happens if I put 0. So if I put 0, this is going to be cos 0. Cos 0 is what? Cos 0 is 1. So cos 0 is 1, 1 times 2, so the magnitude is 2 here. Okay, so this is going to be 2. And if I plug 5 by 2, let's see, look at the 5 by 2. If I plug 5 by 2 for this one, what will happen? 2 times 5 by 2, 2 cancels, so we are going to get cos 5. Cos 5 times cos 5 is 1. Cos 5 is actually, let me double check, cos 5 is 1 or minus 1. Cos here, cos 5. Cos 5 is approximately 1. Yeah, cos 5 is 1. So it doesn't matter, like even if you get negative 1, this is the magnitude, right? So it's going to be turned into positive 1 anyway. So 1 times 2, if it's 5 by 2, then we are going to have 1 times 2, the height is going to be 2 right here. And even if it's negative 5 by 2, the height is still going to be 2, because the the magnitude will turn the negative into positive. Okay, so as you can see, this is gonna be like this, and the pattern repeats. Okay, you can try the other values. You're gonna see the same pattern repeats like this. So this is our magnitude diagram, magnitude plot. Now let's look at the phase plot. Phase plot, as we seen before, we take h of e power j omega, and that is minus 2 omega. For this one also, we take certain values like starting from 0, 5 by 4, minus 5 by 4, and then minus 5 by 2, 5 by 2, and then 3, 5 by 4, negative 3, 5 by 4 here, positive 3, 5, 5, 4 here, and negative 5 here, positive 5. So let's plug 0 here. So if you put 0 for this one equation, that's going to be just 0. So it's going to be like this. And if I put negative 5 by 4, then negative 5 by 4 positive negative 2, that's going to turn into positive. And also this is going to become 5 by 2. So the height is going to be 5 by 2. Okay. And if I plug positive 5 by 4, that's going to be negative 5 by 2. This is 5 by 2 height. This one is, let's say, negative 5 by 2. And if I plug this one, this is going to be like this. And as you can see, this is giving us straight line. And if I try the next one, 5 by 2, so 2 times negative 2 times 5 by 2, that's gonna be 5. Okay, 5 is right here. Negative 2, 5 by 2, 5. 5 by 4. So this pattern is gonna keep on repeating like this. Okay. So you can plug in the values like this. You're gonna end up having a pattern like this, keep on repeating. This is here. Okay, that is our phase diagram for the phase plot for the given system. And that's it for this video. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.